Hey there, everyone. My name is Ryan Jewell. Welcome to my channel. We are looking at video number 3 of 5 total, and we're focusing on Bayesian models, and we have 5 different topics. The topics include classification, regression, A/B testing, natural language processing, and portfolio optimization. And again, we're focusing on Bayesian models to help us understand these 5 different analytical exercises. Okay, so a Bayesian model is a statistical model that uses Bayes' theorem, and it updates the probability of a certain outcome or hypothesis as new information becomes available. So these types of models are very advantageous for several reasons. It incorporates prior knowledge. It incorporates new knowledge or new information as that becomes available. We look at uncertainty quantifications, dynamic updating, interpretability of the model, and overall flexibility of the model. So the classic way to describe this is, let's say that you have an object that's a circle, it's small, it's a fruit, and it's red. What are the probabilities of all of these together? 0.9, 0.8, 1.0, and 0.7. If you multiply these all together, you get a 50.4% chance, 0.4%, that an object peach is an apple. Okay, is an apple. So this is an apple based on these conditions, right, that define what's an apple. And let's say we want to say that the object is not circular, not small, not fruit, and not red. What is the probability that this is not an apple? We have 1.44% chance that the object is not an apple. Is not an apple. Okay, so if all these conditions are true, 50% chance the object is an apple. Okay, and this, again, this is the initial condition. As new information becomes available, we make updates and find out that we are 50.4% chance, 50.4% certain that this object is an apple. And if these conditions are not true, you multiply all these together, and we are 1.4% chance that the object is not an apple, okay? Because it's not, these conditions are not conducive to the definition of an apple. So we're going to look at the canonical iris data set here. We are going to look at our x variable and y variable. This is the independent, this is the dependent. I'm going to pull this in. Right here, this comes from sklearn dataset, pulls from the web. So these are the features right here. Sepal length of an iris flower, sepal width, petal length, and petal width. Okay, and based on that, we can go ahead and set up a machine learning classifier to determine how likely this how likely we can measure these criteria right here, which are the x variables, and predict the y variable. Right, so the y variable target, this can be the target. We want to predict that outcome based on these inputs. Okay, so that's what we're going to focus on here. I'm going to go ahead and refresh this machine learning model. I'm not going to get into all the details here because I have several videos that discuss classification, regression, and how all of this stuff works. Just keep in mind that this is the independent variable and this is the dependent variable that we're trying to predict. So this model is 97.78% accurate, highly precise, 98% precise. Recall and F1 scores, both 98. So we are highly certain that this model is able to ingest the data and make predictions on the target variable, which again, so here, this is the target variable based on these independent input variables over here. We can predict the target. That's what we're doing, okay? So we have all the inputs and the predictive capability of the model. We are going to go ahead and generate predictions right here. And again, don't worry about all the details of the code. I will share this with you later today. When I post a video, you will have everything that you need to go ahead and run this and to make predictions on your own. Again, the focus is on the Bayesian model methodology and how we can use multiple inputs as they become available on a continuous time frame or in a time continuum that is updated frequently and regularly, and we are able to make predictions into the future. Okay, so now we are looking at decision boundaries. Okay, we have 3 boundaries here. 0.00 is blue, 1.0 is in red, and the brown is 2.0. And then we can see, based on our training and test records over here. The training is the circle and the test is the X. We can see how accurately these training and test outcomes fall into these decision boundaries. And we can see the blue pretty much ends up in blue, the red ends up in red, and the brown ends up in brown. The brown bleeds into red just a little bit, okay? And we can tell that the model is not perfect, but it's pretty close, 97% accurate, very precise, high recall, and high F1 score, right? We want these to be closer to 1, so this is perfect. These are all perfect. This is perfect, almost perfect, 0.92, 0.96. But we do have a few shortcomings here, and you can see that the brown is kind of overflowing into the red when it should be in its own. Predictions, but once again, perfect, right? Each column prior probabilities, right over here. Um, of the data and how those labels are assigned, and then the posterior probabilities are updated as new information becomes available. Right, that's what Bayes does for us. The Bayesian model is continuously processing information and making or updates to its posterior probability calculations, as we see here. Okay, new evidence becomes available, and we consume it, and we digest it, and make new predictions. In this case, naive Bayes does not explicitly require manual updates like other models, because it's constantly making calculations updates. Okay. In conclusion, we confirmed that the Bayes update concept, we have the before update. This model uses the initial data to compute prior probabilities and the likelihood of those probabilities being labeled as a certain feature. And after the update runs, the model updates its internal probabilities based on new data and makes revisions to the original estimates as that new data becomes available. So that is it in a nutshell, guys. Hopefully that was helpful and useful to you. I like this stuff. I think it's the answer. Meaning to do these naive Bayes models for a little while. I finally got a chance to do that, so I'm going to be putting those out today. I'm going to have a series of 5 total with you. Hopefully it's insightful and informative and useful as well. So here, thanks for your time today. Enjoy the rest of your day. Bye.